Good day. In today's lesson, we are going to look at intersecting lines, tichiri kuita vectors 2. So the first point we are going to write here is, kana tichiti ma lines are intersecta, what do we mean? Saka two lines intersect if the value of each of the parameters is constant. Saka two lines intersect if the value of each of the parameters is constant. I want us to remember what we said concerning the equation of a line, kana tiri kuma vectors. So the equation of a line, takati it's given by r is equal to a plus lambda b. Saka kana mchirangarira, takati a iri kutaura a point on the line, tikati b iri kumiririra direction vector, then we also said this lambda iri kutiudza about the parameter. Saka kana chida kuziva kuti ma lines ari ku-intersect here, and by intersection tikureva kuti, let us say this is R1, this is R2. Saka this will be the point of intersection, kukatana, kusangana kwema line. Saka this point of intersection, kana tiri ku coordinate geometry, ndiyo yataiti the simultaneous point. Saka pakusolva kwedu tichida kuziva if two lines under vectors are intersecting, we are going to be using the parameter, the lambda. So let us go through 3 examples which are going to illustrate this. But before we go there, tofunga kuziva kuti if two lines, and 2 is very important, panapa tungodila ne 2 lines. So if two lines do not intersect, they are called skew lines. Saka kana tichitaura about skew lines, tikutaura ma line asingasangani. We can talk about this line and maybe that line. Saka they are not, this will be our R1, our R2. Saka they are not intersecting at any point, correct? They are skew. Let us now work through our practice questions. In our first example, we are given 2 lines. Saka line redu kutanga, r is equal to 1, 2, 3 plus t 1, 2, 1. Then our second line, r is equal to 3, 2, 4 plus s minus 1, 0, 0. We want to determine if these 2 lines are going to intersect. Kureva kuti we are going to be using our parameters. Saka parameter in the first line dt, parameter in the second line ds. Zvatinoita panapa tinodai, tinoti r is equal to, we are going to solve this part, kana kuti to further simplify. How do we further simplify? We further simplify through scalar multiplication. Saka panapa tikauya tikata reproduce 1, 2, 3 sezvairi, totati plus, then we know kuti this t, this parameter, is going to be multiplying every term inside the bracket. Saka inge ya t times 1, yova ya t times 2, yoti t times 1, like this. Saka this is equal to 1, 2, 3 plus t times 1 dt, t times 2 dt, t times 1 dt, seizvi. Saka panapa tichishandisa maedhera tinoita ma vectors, we know kuti this is going to be 1 plus t correspondency, 2 plus 2t na 3 plus t seizvo. Saka tatopedza ne the first line. We are going to do the same for the second line. Saka for this line tichati r is equal to, togona ngosvitaka 1, saka this is 3 plus s times minus 1, saka it's 3 minus s. Then up it's 2 plus s times, this is 0, kureva kuti inongoramba iri 2 since s times 0 ari 0, panapa futi yoramba iri 4 like this. Saka tasimplify, taita further simplify our lines. After we have done that, what we are going to do, we can actually write a small sentence panapa. So the sentence would be, if lines are intersecting, saka if lines are intersecting, r should be equal to r. And saka question yedu yatipa iri r, kuri kuti vanga vati r1 r2 zvaimeka sense. Saka panapa deni yanga iri r1, panapa iri r2, zvoreva kuti panapa r1 will be equal to r2, but hatitenderwi kuita edit in zvatinopiwa nequestion unless tatoita state before tatombonyora everything kuti we want to let r yekutanga be r1, rh2 be r2. Saka pano we are going to take this 1 plus t, 2 plus 2t, 3 plus t. This should be equal to 3 minus s, 2 na 4. Saka panapa zvatakuchiita takuchiti first row ndokunotonyorera kuno to save space. Saka ndikauya panapa ndikati first row. Saka pa first row tina 1 plus t is equal to 3 minus s, and this is the first row. Iyi ndo yatiri kuti first row iyi. Mapavaona, this is the first row. Okay, saka since mane an idea of what a row is, second row it's 2 plus 2t is equal to 2. Saka second row yedu, as you can see, tinogona kuita further simplify. 2 ino itikaendesa uku inova 2t is equal to 2 minus 2. Saka 2t inenge iri equal to 0, kureva iko kuti t iri equal to 0 over 2, which is 0. Saka value ya t tatoiwana. Value ya t taiwana. Okay, saka tawana the value of t panapa. Let us do the third row. Let me use the same color. Third row. Saka third row it's 3 plus t is equal to 4. Saka t taona ari 0. 3 plus 0 is equal to 4. Saka since tatoona out the value of t cannot be both 0 and panapa 1. Zoreva kuti the lines are skewed. Kana kuti makunonyora mchiti the lines do not intersect. You can put it down like that. Okay, let us look at another example. In this example, taudzwa kuti r is equal to 1 2 3 like that, plus t 1 2 1, and ndokuudzwa futi kuti r is equal to 3 6 5 plus s 1 minus 2 0. Saka in essence vatiri kuita tiri kutsvaga ma-coordinates. Ma-coordinate, the x coordinate, the y coordinate, and the y coordinate. Remember kuti our column for 3-dimensional vectors x, y, z. that's why tichizoequata zvino, because techiequata ma-x coordinates pawega, ma-y coordinates nema-set coordinates pawega. Saka this is the underlying philosophy of what we are doing, and I'm going to show you what we actually mean. Otherwise, let us simplify bekutanga. R is equal to, saka panapa it's 1 plus t times 1, then apo it's 2 plus t times 2, then apo 3 plus t times 1, like that. Kureva kuti r inge equal to 1 plus t, 2 plus 2t, 3 plus t. Saka this is the x, the y, the z. Tozvita futi kunoku. Saka pano r equal to 3 plus s times 1, 6 plus s times minus 2, then apapo it's 5 plus s times 0. Saka r equal to 3 plus s times 1 the 3 plus s, 6 plus s times minus 2 the 6 minus 2s, then 5 plus s times 0 inogoramba iri 5. Seizo, this is xyz. Saka takuchita chi equating coordinates. Saka pakuita equate ma coordinates apo tiri kutora 1 plus t, but I think it's very important to specify kuti tikutanga ne first row. Totora 1 plus t and it equal to 3 plus s. Okay, saka panapa we cannot solve it any further. Let us go to the second row. 2 plus 2t is equal to 6 minus 2s. Okay, can we simplify it any further panapa? Let us go to the third row. Third row 3 plus t is equal to 5. Zvinoreva izvo kuti t inge equal to 5 minus 3, kureva kuti t is equal to 2. Saka ndo patatangira pano taona kuti t are equal to chi to 2. Saka t anofanga kuramba ari equal to 2 throughout kuti ti conclude kuti the lines are intersecting. Saka tadai tinogona kubva tazoti tadzokorodza second row, but this time takusubstitute t na 2, kureva kuti yava 2 plus 2 multiplying t should be equal to 6 minus 2s. Anditika? Saka t ndi 2 andika? Saka it's 2 plus 2 times 2 is equal to 6 minus 2s. Saka this is 2 plus 4 which is equal to 6 minus 2s. Saka 4, 5, 6. Saka 6 is equal to 6 minus 2s. Minus 2s ikawea uku, 6 ikaenda uko, like this. Saka since you have 2s is equal to 0, so s should be equal to 0. Okay, saka let us test this tichishandisa the first row. Saka takudzokera futi kuchi ku first row kuti tione kuti zvinoramba zviri consistent here. Saka tikaenda ku first row tinoona kuti this is 1 plus t ndi 2 which is equal to 3 plus s ndi 0. Saka 1 plus 2, 3 is equal to 3. Saka taona kuti the value of t is constant and the value of s is constant because they are balancing off inside those three equations. Saka tadaro tieta kutongo conclude kuti therefore the lines intersect. Saka this is how we test if the parameters are constant. Tinoma testa pa all the three equations: first row equation, second row equation, third row equation. They do not necessarily, t na s should not be equal to each other themselves, but they should be in such a way that if we applied them consistently throughout the three equations, they are always going to balance off the equations. Mapabata. Let us do another question. So question iri kuti determine whether the lines r is equal to 111 plus t 011 and r is equal to 011 plus s 20 minus 1. Determine whether the lines where t and s are parameters intersect. Saka answer yedu, so it's either going to be the lines intersect or it's going to be the lines are skewed, do not intersect. And saka let us work through this. Ngatitangene ku simplify this. R inge equal to 1 plus t multiplying 0, 1 plus t multiplying 1, 1 plus t multiplying 1. Then pana r is equal to 0 plus s multiplying 2, up it's 1 plus s multiplying 0, then up it's 1 plus s multiplying minus 1. Like that. Saka r pano is equal to 1 plus t times 0 in number 1, 1 plus t times 1, that's 1 plus t, 1 plus t times 1, 1 plus t. Then panapa r is equal to 0 plus s times 2 and the 2s, 1 plus s times 0 and the 1, 1 plus s times minus 1 the 1 minus s. Like this. Saka tadai so azvichanetse handiti takungo equator. Saka first row 1 inge iri equal to 2s. Saka let us simplify, divide both sides na 2 panapa. Tinoona kuti s is equal to 1/2. Okay? Let us see. Saka s should be constant. Ndochekutanga kureva kuti s in all situations should always be equal to 1/2. Uye kana tazotora s na t, they should balance off equations. That's how these parameters remain constant. Second row. Saka mofunga kuita for first, second and third row. Saka second row 1 plus t is equal to 1. Kureva iko kuti t inge equal to 1 minus 1. Saka t is equal to 0. Like that. Third row 1 plus t is equal to 1 minus s. Saka since tana s na t tofango kushandisa both s na t. Saka panapa it's 1 t ndi 0 plus 0 is equal to 1 minus s ndi half. Saka mukazviona 1 plus 0 ndi 1, this is not equal to half since 1 minus half is half. Therefore the lines are skewed. Tatopedza. Maona kuti zvinoitwa sei. It's simple as that. Okay, let's do another example. Example yedu iri kuti determine whether the lines r is equals to 142 plus t 12 minus 3 and r is equals to half 34 plus s 12 minus 4 intersect. Saka tapiwa r is equal to 142 plus t 12 minus 3 and r is also equal to half 34 plus s 12 minus 4, like that. Saka kuno r is equal to 1 plus t multiplying 1, 4 plus t multiplying 2, 2 plus minus 3, which is multiplying t. Then kuno uku r equal to half plus s multiplying 1, 3 plus s multiplying 2, 4 plus s multiplying minus 4, like this. Saka zvaitwa nemutoo uyu zvongoreva kuti r pano iri equal to 1 plus t, 4 plus 2t, then apo it's 2 plus minus 3 times t ndi minus 3t, saka it's 2 minus 3t. Panapawo r inenge iri equal to half plus s, 3 plus s times 2 ndi 3 plus 2s, then apo ndi 4 minus 4 times s minus 4s, like this. First row ndi 1 plus t is equal to 2 half plus s, we cannot solve it any further. Second row, 4 plus 2t is equal to 3 plus 2s, we cannot solve it any further. Third row, 2 minus 3t is equal to 4 minus 4s, like that. We also cannot solve it any further directly. Saka pano zvatichaita, we take any two equations. Togonotora first row ne second, first ne third, third ne second, third ne first what, however you elect to do. But since panapa paine fraction, I think it better. Alright, let me take the first and the second row. Saka consider first and second row. So toda masolve simultaneously. Saka panapa tiri kuti 1 plus t is equal to half plus s ndo inenge iri equation number 1, whereas tikada ku clear ma fractions nekumultiply everything na 2, tinoona kuti 2 plus 2t inenge iri equal to 1 plus 2s. Saka ndo yava equation 1 yedu. Equation 2, 4 plus 2t is equal to 3 plus 2s. Equation 2. Then pano tadzokera ku level tochoose toda ku eliminate ipi. It's better ku eliminate t because yagara togona futi ku eliminate s in such a way. Saka mukatarisa pano munoona kuti tikada ku eliminate t neku subtract kunoku, you see kuti tichati 2 minus 4 towana minus 2, then 2t minus 2t, that's plus 0, then panapa 1 minus 3 ndi minus 2, as 2s minus 2s, that's also plus 0. So conclusion yatinoita panapa ndeyekuti if we are to solve the first and the second equation, tiri kuzoona kuti we have no solution. Hatina solution ya t kana solution ya s, since the lines have no common point. Saka no solution for t and s means the lines have no common point. And kana taona kuti my lines are na common point, therefore the lines are skewed. Saka hiyo ndo imwe proof yatinoona nayo kuti the lines are skewed, kuti zvaramba kusolveka simultaneously zvakanselana. So that is also how we make our conclusions. So I hope for the 4 examples ataita, you now have a fair chance of understanding what we mean by intersecting lines. If you find these lessons helpful, may you please consider liking, subscribing and sharing. Otherwise, thank you. And those who want to join our Pure Maths class, you can WhatsApp us on +26371 521 3310. Thank you and take care.